All right, guys, so this is page 69 in our notebooks, and I'm just going to do a whole bunch of graphy ones. So what I would suggest is that you try them out first, and you could even try them out one by one, and then maybe take a pause, and then come back and check my answers. So like if you want to try this first one here, try it out, and then come back in a second, and you can see how you did. And I'll show, like, I'm going to go through all four on the front, and then I'm going to go straight across the top in the middle. So I would suggest that it's really up to you though. So if we graph this first line, this is in y equals mx plus b. So I would start at my y-intercept of 3 and then do my slope of -1. I'm just looking around. I want a straight edge. I want a real straight line. Now again, with these ones, I like to do lots of dots because I can look for exactly where the two lines meet if they do. And so for this one here, I could rewrite it in y equals mx plus b, or since it's in standard form, I can boop out the y and solve for x. So x is 3, 1, 2, 3. And then I can boop out the x and solve for y, and y is 3. So these lines actually end up being right on top of each other, which means that you have infinite solutions because they are touching all the time. Okay, go into this one if you want to take a pause and try it and then come back and see. Right here, if I graph this line, this one has a y-intercept of 0 because there is no add or subtract, so it starts at 0. And then we do our slope of up 2 over 1. We're down 2 back 1. So we get this line here. Then if I do the line under it, that's also in y equals mx plus b, where the y-intercept is 3, and then my slope is -1. See, dude did right there, touch that spot. So the solution of this guy is right where they touch each other, which happened at this point, which I want to write unordered pairs like x comma y. So it's 1 over and 2 up. So 1 comma 2. Okay, I'm going to go down here and do this one next. So that top line is in standard form. Now you could rewrite it, but I'm just going to find the x and y intercepts. So if I ignore y and solve for x, I find that x is 2 because I divide both sides by 2. And then if I ignore x and solve for y, I have that y is 4. 2, 3, 4. And then I can just connect the dots. The bottom line is in y equals mx plus b. So I would plot the y-intercept, which is 4. And then do the slope, which is down 2 over 1, down 2 over 1. And it seems like I'm touching all the spots. So I'm pretty sure, yeah, those lines are the same. So if that's the case and they're touching all the time, that means I have infinite solutions. Okay, and then last one on the front, if you want to take a pause and try it. That top line is in y equals mx plus b. The y-intercept is at -4, so I'll start on the y-axis at -4. And then I'll do the slope, which is up 3 over 5. 1, 2, 3, 4. That's really all I can fit on here. Now that bottom one has no slope, or 0 slope, or just a y. And when you're just a y, you're a horizontal line through that number, which is -4. 1, 2, 3, 4. So it's horizontal right through there, which I don't know why I didn't grab my straight edge for that. That curvy swervy line is going to drive me bonkers. But these two lines do touch at one point. So their one solution is over 0, but down -4. Okay. So now opening it up, we got a whole bunch. So I'm going to start at the top and go straight across. So with this one here, if you want to take a pause and try it. Now this line is in y equals mx plus b. The y-intercept is -2. And then I would go up 3 over 1 for my slope. Up 3 over 1. I want to get a nice straight line, even though I'm on like the edge of my notebook. And then that bottom line has a y-intercept of +2. So we'll start at +2. And then has a slope of up 1 over 3. 1, 2, 3. Or down 1, back 3. 1, 2, 3. This one's kind of sneaky. Did I goof up somehow? I don't think so. Now the reason I'm like feeling like I goofed up somehow, -2, up 3 over 1, +2, up 1 over 3, is because they don't cross at a super nice spot. Like the doots didn't touch, like the little points didn't line up. Now they do cross, so it does have a solution, but I feel like I'm going to have to guess what it is. So I'm glad we actually had one like this because it's not great to guess. So later in the chapter, we are going to talk about ways that you can find the exact answer, because right now I'm going to sort of have to guess. Now, this point right here where they're crossing is like kind of over 1.5, but is it right in the middle? I don't know. It's kind of hard to say. So I'm going to put like 1.5-ish. Like it kind of looks like it. And then it's up 1, 2.5. I don't know. It's kind of hard to tell. It's like 2.5-ish. And it's not great to have ish answers. So eventually we're going to talk about how we can find, like I said, exactly where they cross. Now I can see that they are going to cross. So we'll do the best we can for now, but eventually we're going to want to find that real answer. Alrighty, this guy here is in y equals mx plus b. The y-intercept is 0 because there's nothing being added or subtracted. And then the slope is 1 because there's no number in front. So it's a hidden 1. So we get this line here. And then that bottom is also in y equals mx plus b, where your y-intercept is 5. And then our slope is down 2 over 3. Oh, thank goodness. Yay, the boops. They touched. I love it when the points line up just so, because then I know exactly where my answer is. I don't have to make a crazy-ish guess. So these points touch at over 3, up 3. So 3, 3. Okay, going right across the top here. This first line is a horizontal one, like we talked about before. A horizontal line going through 4. So 1, 2, 3. Wait, 1, 2, 3, 4. Now, hopefully it kind of makes sense, but if a y equals a number is a horizontal line, then an x equal a number will be a vertical one through that number. So -2 is right here. And this is just going to be a vertical line. And those two lines do touch just once right here at the point -2, 4. Which, I mean, hopefully it's not a huge surprise that like x is -2 and y is 4. Like that's kind of crazy, right? Or is it? On to the next. This top one here is in y equals mx plus b. Your y-intercept or b is at -5. And then we'll do our slope of -1. And I can't really go down 1. So I'm going to go up 1, back 1. And get all these doots, these little doots. And then this bottom line is also in y equals mx plus b, where your y-intercept is 4. So 1, 2, 3, 4. And then I have a slope of up 4 over 5. And I can't really go up 4 over 5. Like, it just doesn't fit. So I think I'm going to have to do double negative, which will keep it positive. So 1, 2, 3, 4. And then back 1, 2, 3, 4, 5. Whew. That like just fit on here. Which it's like worth it to say, just because you can't see where they cross, if you know they're going to cross, they will have a solution. So that could be real tricky. And that's another reason why solving a system by graphing isn't necessarily great. Because if this graph had just been a little bit smaller, I may not have seen where my solution was. I knew it would have one because the lines are going to cross. But if I can't see it because of like how small my graph is, I don't know what to put down. Now, in this case, we did get lucky, and we can see that it's crossing at negative 1, 2, 3, 4, 5, comma 0. But eventually, we're going to need to know those other ways to solve in case my graph's not big enough. Alrighty, jumping down here, trying a couple more. I'm going to go straight across. Just so looking at this first one here, that's in y equals mx plus b. So we'll plot our y-intercept at negative 4. And then do our slope of negative 2, although I can't really go down 2 over 1. So I guess I'll go up 2 back 1. So we get this line. And then the one below it has a y-intercept of 1 and a slope of negative 2, so down 2 over 1, down 2 over 1. Oh, I see what's going on here. These lines are parallel, which means no matter how far I go, they will never touch. So no solution, because those lines will not cross each other. Alrighty, on to the next. Now this guy is in standard form, and you could rewrite it, but I kind of like not having to do that. So I can just ignore y and solve for x. And so I divide both sides by 2, and x would be 3. So I go on the x-axis to 3. And then I find the y-intercept by ignoring x and dividing both sides by 3. So y would be 2. And then I can just connect the dots and get that line there. And then the bottom line, same idea. That one is also in standard form, so I'm going to keep it that way. I just like to not do extra stuff if I don't have to. So if I ignore y, I can see that x is 3. So that would go right there. And if I ignore x, then I would have to solve for y, and I would get that y is 1. So right here, ooh, I thought they were going to be the same line, but they sure aren't. These lines are almost the same, but not quite. And they do only touch at one spot, so they have one solution, which is over 3 up 0. So 3 comma 0. Okay, on to the next. This line is in y equals mx plus b. So I would plot my y-intercept at negative 1 and then do my slope of up 3 over 2. So up 1, 2, 3 over 1, 2. 1, 2, 3, 1, 2. Or down 1, 2, 3, back 2 to get that cute little line. And then your bottom line is in standard form. So again, I would ignore the y. Ooh, that's not great. Like, I'd have to divide by 3, and that's 2/3. Ugh. Maybe I should solve for y. I'm going to solve for y. So let's subtract 3x both sides. And we'll have negative 2y equals negative 3x plus 2. and then divide it all by -2. So we end up with y equals, now a negative divided by a negative is a positive, and 3/2 is just 3/2. Positive divided by a negative is a negative, and 2/2 is 1. So now I can see that my y-intercept is at -1. And then my slope is 3/2 again. Oh my word, that is the same line. So if it's the same line, line on top of line, they're touching all the time. Does that kind of rhyme? I don't know. You got infinite solutions though, because they are crossing all the time. Alrighty, last one. Save the best for last, I guess. I don't know if anything cool happens. It's probably just normal. I'm going to try to keep this one in standard form. The only reason I didn't over here is because it was not a nice number, but if I boop out the y, I can see that x is 4. And if I boop out the x, I can solve for y, and that'll work out pretty nicely. It's -2, so like that's not so bad. But like over here, when I was going to divide the 3, like 2 divided by 3 isn't great. So that's why I changed the form. Now you can always change the form if you want. I just try to save myself some time and keep it in standard form if I can. So at this line here, it's in standard form again. So if I ignore the y and solve for x, I would divide by 2. So x is -1. And then if I ignore the x, y is already alone. So y is -2. Oh, look at that. Love it when that happens. Those two lines are going to touch just once right at that spot, which is at 0, -2. So hopefully that was a good graphing practice. We understand about solving for a system, and we'll talk more about it tomorrow or next week.